Thank you, Mr. Chairman. Thank you very much for your work as part of this process and for being here to help us understand better the process that you went through in crafting and writing the standards. I guess my first question is in reference to the last part of your testimony where you spoke to calculus. It's my understanding that nothing in Common Core state standards would preclude districts from having acceleration policies and working with students who were working ahead of a curriculum at a particular grade level, whether it's subject-specific or whole grade acceleration or any of those kind of policies. Districts still have the latitude and the ability to work with the needs of individual students, would they not?
Exactly. The standards do not preclude that at all, just as previous state standards never did. I just want to say the standards, that's all they are, they're standards. And they're not different in structure or in nature of their being from previous state standards. I think they're an improvement in their quality. And it's always been true that some districts, some parents, some schools will provide acceleration schemes for students to help them get to calculus or even beyond in high school, and they will continue to do that. Nothing has changed there. The only thing I would say has changed is because the Common Core has this solidly built progression, acceleration should not mean leaving topics out. It should mean compressing. And sometimes in the past, acceleration has just meant omitting things, which then gives students a very weak basis for what they're doing. But absolutely, there's nothing in the Common Core about implementation, about acceleration schemes, about curriculum. That's all up to local school districts and states, as it always has been, as it should be.
Yes,
Thank you. And I specifically want to ask about a topic that was raised by a couple witnesses last week. There were a couple of witnesses who talked about the geometry standard, and they said that the methods that were supposed to be used in Common Core were experimental, and why would we abandon what has been so successful in teaching geometry over many years? So can you talk? I looked at the standards, and although it's a while since I've taken geometry, it all sounded like stuff that we had to do, and having to do proofs on all those different theorems looked to me like those things were in the standards. So could you talk a little bit about
I know where that criticism is coming from, and it's based on a complete misconception about what's in the standards. It's based on a belief that the standards are about a sort of transformational geometry curriculum that was applied in Russia in the 50s or something. It's not that. The word transformation is in there, and I think that's what's gotten people onto that other track, but it's not right. It is true that the geometry standards have an innovation in Euclidean geometry where they teach Euclidean geometry, but not from that very sort of dry beginnings that I don't know if any of you remember going through all those axioms at the beginning. They come in a level where you're starting to prove interesting theorems, using transformations as an entry into that. But from that point on, it's the geometry that you know. It's probably the part of geometry that you remember because it's probably the part that was more enjoyable. It's rigorous. Students have to write proofs. They have to prove the same theorems about triangles that they had to prove before. It's just not as different as the critics make it out.
Thank you very much. That's helpful. And there was one other criticism that we heard from several different witnesses last week. There were people who referred to bad memories of new math and the notion that somehow it didn't matter whether students get the right answer under these standards. If they could explain how they got it, everything was going to be okay. And that doesn't sound right to me, and I wonder if you could talk a little bit about the kind of showing the thought process and arriving at the answer and how that fits in these standards.
Yeah, so I want to say it's completely untrue that the standards somehow think it's okay to get wrong answers. It's not. Students have to get the right answers to math problems. And in fact, I would say the standards are more rigorous in that regard than many previous state standards. They've been very clear on that point, clear on the students' fluency with the standard algorithms, clear on for standard operations and arithmetic, clear that they have to solve multi-step word problems, whereas previously often they didn't. So I think there's more rigor there. There is also a requirement that students understand what they're doing. So I'm sure that many people in this room from their own math education remember that they could get the right answer, but then when they went out into the real world, They sort of stopped using math because they didn't really quite know why they would use it. Knowing how you got the answer you got gives you a flexible knowledge that you can use the mathematical knowledge you have to apply to situations in the real world, in your profession, in your career. So there is a requirement students understand, not just do.
Representative Ramos?
Thank you very much, Mr. Chairman. Thank you, Professor, for being here. Last week there was a criticism on potential application of the teaching of basic arithmetic, basically multiplication. They said Common Core doesn't teach multiplication in the old way, which is memorizing the tables, basically. But rather it's say if you need to figure out what 5 times 4 is, you figure out 5 times 2 is 10, and then you take 5 times 2 plus 5 times 2, as opposed to the old way, which was 5 times 1 is 5, 5 times 2 is 10, 5 times 2.
Right.
But then you mentioned that one of the issues when you were developing the standards that was brought to you by third grade teachers was the importance of the multiplication tables. So last week they said that's not linear. Can you clarify, is the teaching of multiplication tables still part of it?
Explicitly required in the third grade standards, and I'd be happy to send you the standard that says it. It says, by the end of third grade, students will know their multiplication facts from memory. I don't see how you can be more explicit than that.
Very helpful. Thank you.